Hey guys, welcome back. I hope you had an opportunity to watch the videos on adding, subtracting, and multiplying that deal with radicals. And now I'm going to teach you how to rationalize. I don't know why I wrote how do we rationalize denominators that have radicals in them. Okay, so typically teachers will always say that you can't have a square root in the denominator. That's a lie, but nevertheless, we will figure out how to get rid of it. Well, the first thing that you need to know is that square root of 2 times square root of 2 is really the square root of 4, but that's just 2. Square root of 3 times the square root of 3, that's the square root of 9, but that's just 3. Square root of 7 times the square root of 7 is equal to the square root of 49, but that's just 7. In other words, when you multiply the same number that has square roots, it makes the square roots disappear. So square root of 3 times square root of 3 is just 3. Same thing with 7 and any number. So that's what we're going to do here. We're going to multiply the top and bottom by the square root of 7 in this case. 5 times the square root of 7, remember we looked at multiplying, you just multiply number times number, radical times radical. So really, this is just 5 square root of 7. Square root of 7 times the square root of 7 is just 7. And you're done. You rationalize the denominator. So in later problems, I'm going to show you how to do the more complicated ones. But for now, let's just practice. Here, I'm going to have to multiply by the square root of 3 times the square root of 3. Over square root of 3. This will give you 2 square root of 3, and then square root of 3 times square root of 3 is just 3. Now, you might ask yourself, like, why do we do this? What we're really doing, if I asked you what's the square root of 7 divided by the square root of 7, you would tell me 1. X divided by x is 1. Y divided by y is 1. Any number divided by the same exact number is 1. So what we're doing is we're really not changing the problem by multiplying it by radical 3 over radical 3. What about this one right here? This one's a little bit tricky. I'm going to multiply this by the square root of 90. So I'm going to have 5 square root of 90 over 90. But there's a huge problem. Square root of 90 is not in simplest form, and you have to make it in simplest form. So first and foremost, we know that we can cross cancel. 5 goes into 5 once, 5 goes into 90 18 times. So this actually right now is the square root of 90 over 18. Then what we're going to do is we're going to break up 90 to 9 times 10. And then we're going to take the square root of 9, which is 3, keep the square root of 10, and then we're going to have square root of 18. 3 hits the 18, you get 1 over 6. And now you're absolutely done. Please do not divide numbers by radicals. You cannot do 6 and 10 have 2 in common. So this is actually the final. Some of you like to break up the square root of 90 very early. You could, I just don't. So your answer is rad 10 over 6. If that was too quick, you can watch it again, but let's do it here also. Square root of 63 divided by the square root of 63. So, do you guys know what 60? So this is this. Let me not go too fast. This times this is just itself. Square root of 63. Oh, that's 9 times 7. Okay. Square root of 9 is 3. So that's 6 times 3 times square root of 7 over 63. 6 times 3 is 18. And then you can reduce it, or you can reduce it even earlier than that. But I'm just going to say this is 18 square root of 7 over 63. They both have 9 in common. 9 goes into 18 twice. 9 goes into 63 7 times. Your final answer is 2 square root of 7 over 7. Once again, you are not allowed to put 7 into 7 to make 1. You cannot divide numbers in square roots. Okay, so I hope this made sense. Look, it's very simple. You square root of 63, but the hard part is really breaking it down right here. Okay, so these are monomials. Basically, in the numerator, it's a monomial, and in the denominator, there's a monomial. So those are just very, very basic. When you get to our next problem where we see a binomial, you're going to have to multiply it by its conjugate. Now, many of you remember from the last video that conjugates, when you multiply them, they give you whole numbers, right? They give you sort of integers, rather. So whole numbers are integers. So the conjugate of 3 plus radical 5 is 3 minus radical 5. So you do that first. Let's multiply out the top. 2 times 3, 6. 2 times negative 1. Remember, there's a negative 1 from the last video. 2 times negative 1 is negative 2, square root of 5. So that's the first part, right? It's like foiling. It's like distributing. Once you get there, do you guys remember how to multiply conjugates? All you have to do is square the first number that you see, which is 3. Always a minus no matter what. And then square the 5. Square the square root of 5, which is 5. So that's going to be 4. They all have the number 2 in common, so you need to reduce it. How do we reduce it? If this number, and this number share a number, you need to reduce it. How many times does 2 go into 6? 3. How many times does 2 go into 2? 1, square root of 5. How many times does 2 go into 4? Twice. You don't need to put that 1 there if you don't want to. Now, if people are still confused about this, you can watch the last video, or I'll just show you really fast. 3 times 3, 9. 3 times negative radical 5, negative 3 radical 5. Positive 3 times radical 5. And then positive times a negative is a negative. Radical 5 times radical 5 is radical 25, which is a 5. These cancel out, and that's why I got this. Okay, but watch the previous video and you'll understand it quicker. So this is how we do that. Let's do one more right here. Multiply by the conjugate. Why? Because we can't have a radical in the denominator. 4 times 5 is 20. 4 times radical 2 is 4 radical 2. Square, and then square. Okay, you don't have to do the insides basically. So 20 plus 4 radical 2 over 23. Since 23 is a 23, 20, and 4 don't share a number, this is your final answer. Once again, guys, if you're wondering how to multiply conjugates really quickly, square this number, and always put a minus sign between them. Okay, final. 2 plus radical 5 over 2 plus radical 5. Okay, I know what the bottom's going to be. I hope you guys do too. 2 squared is 4. Always a minus. Square root of 5 is 5. Okay, 4 times 2 is 8. 4 times radical 5 is 4 radical 5. 2 times radical 3 is 2 radical 3. And radical 3 times radical 5 is radical 15. So I have 8 plus 4 radical 5 plus 2 radical 3 plus radical 15 all over negative 1. Now, I always say this to my students. Nobody likes a negative in the denominator. If you want to get rid of the negative in the denominator, what you'll have to do is change every single sign in the front, in the numerator. This one, this one, this one, and this one. And then obviously change this to a positive. Well, leave your comment, ask any questions, and I hope to get back to you. Have a great day.